to start vectors, so we've already done acceleration, and now we're going to go on to vectors. And when we're looking at vectors, we have to know the difference between a scalar and a vector quantity. That's kind of one of the big topics here. So a scalar quantity is just the regular old numbers that we have always used. So 14 seconds, it has a unit and it has a number out in front. Okay, so this section we're going to be looking at vectors and scalars. So the first thing with scalars, it's just a unit of measurement that involves no direction. So we're talking things like 12 seconds, 14 grams, 32 liters, okay? It has a number and a unit associated with it, but it does not have a direction. A scalar quantity. So that's what we've used all the time. A vector quantity has a direction. So it is a quantity, it has magnitude and direction. And when we say magnitude, we mean it has a number and a symbol. That's your magnitude. And it also has a direction. When we look at this thing, we kind of think of it as a compass, but this is the coordinates, okay? North, south, east, and west. And that's the coordinates that we are always going to use here. So displacement, velocity, and actually acceleration is a vector quantity. Okay? So when we look at vector quantities, in order to show that, we are going to put a little arrow over top of our symbol. So that little half arrow, that tells me that an acceleration is a vector quantity. Okay? I know velocity is a vector quantity. So V without the arrow is speed. If I put the arrow on top, I'm now talking velocity. If I have delta D, that tells me it is a change in distance. If I put an arrow on top, that means we are talking displacement, which is something different, okay? So a vector quantity requires direction. A scalar does not. Okay. If we have a direction, one of the things we can do is say maybe 30 meters per second forward. We're going to start putting the directions in square brackets, okay, because that is usually how you see them. So 30 meters per second forward. "20 kilometers east." Notice this one has that square bracket. It's not the rounded, it's square. So this would mean the object went 20 kilometers in the east direction. So from the start in that direction, east, it went 20 kilometers. 20 kilometers east. Okay, so let's look at this. A helicopter takes off from point A and flies forward 30 kilometers and lands. So he's going to go forward. Generally, we have forward going towards the right. So he goes 30 kilometers forward. And I have to, this little line with the arrow at the end, it represents the vector. It tells me that I am going east or forward. Okay, so the arrow is pointing in the right direction. Okay, he lands there. Then it says if the helicopter then takes off again and flies 40 kilometers forward in a straight line, so another 40 kilometers in a straight line, should be asking how far is it from its original position. So put an X from the start point, okay? And you don't have to use the word start after you're good at that, but until then, the X represents the start point. I went 30 kilometers and then 40. So how far away am I from the original position? 70 kilometers. I am 70 kilometers east or forward. How far? I am 70 kilometers east. So the two arrows, 30 and 40, 70 kilometers forward. Okay, let's look at problem B. Okay, looks to be pretty similar, but it's not the same. Again, we have a helicopter. Takes off from point A. It flies 30 kilometers forward. Okay, so I'm going in this direction. I'm going 30 kilometers and lands. Great, I've got my arrow here to prove that I'm going forward. It's going to take off again, and now it's going to fly 40 kilometers backwards. So from this arrow, I am going back. Oh, that's a straight line, believe it or not. There, 40 kilometers back. Okay, this guy is forward. And this one is back. How far am I away from the original position?
Kilometers west.
No, well, sometimes if it was a number line, sometimes you would see that minus in there. But if we are looking here, this is where he stopped. This is the original position. So he is now 10 kilometers back from the original position. Okay? That is equal to his displacement, delta D. Displacement is the straight line segment from beginning to end. I could also look at distance. In this question, how far did he travel? Yeah, he went 70 kilometers. When I say distance, there's no vector on top of that variable, and so I'm not going to require a direction. And so I'm going forward 30 and back 40. Go through all this again. Okay, so distance. It's the length of the path traveled by an object from point A to point B. There is no direction required for distance. Okay? And we want to put here distance. The symbol is a D, which we know that. Distance, the symbol is a distance. This is your change in distance. And the unit is a meter, or like a kilometer, a millimeter, one of those. And we, although it's not SI unit, it is a mile is something we still use sometimes. So if I went between home and school, that pathway would be your distance. Okay, so Peter must go to school is shown. He travels a distance of 5 kilometers, which can be represented as delta D is 5 kilometers. No direction, really important. Distance is scalar. Okay, position. The location of an object relative to a reference point. Direction must be specified. You have to put it in there, okay? So it's D with a vector, but usually we talk about displacement as being delta D, okay? SI units are meters again. Sometimes we use a mile and its prefixes kilometer, millimeter, etc. Position of the school is going to be D is equal to 5 kilometers east. Okay, so position, and I think I said that incorrectly there. Position is different than displacement. Position is a direction, and it has to have that reference point. And the reference point is of Peter's home. Okay? He's 5 kilometers east of Peter's home. Okay, position. So where he is. When we have position, we need size or magnitude. So size and direction, or sorry, size and units. It needs to have a direction. Your direction will be in square brackets. And it needs to have a reference point, okay? So we are going east of the school or east of the swimming pool, whatever that starting point is. Okay, now we have displacement. So when we're looking at displacement, it's a change of position. And you do have to have direction. Notice here that we have the vector on top. The arrow is there. Okay, so it's your change in position. We have to have a vector, a direction in there for a vector quantity. We no longer have to have a reference coordinates. You do not need to mention the reference point. Displacement is your delta D, and it would be 5 kilometers east. It's a straight line segment from beginning to end. Okay, so this is a good example here. This, we know we're starting at this red X. And I know that because there are arrows on my lines. And this tells me from my start, I have to be going, this has to be my end point. Okay? Because of that arrow. Now, if you're taking a car, you might have to travel this road. Okay, that might be the road that takes you between the station, the university station, and Taipo Market Station. Okay, that would be the road. That amount is 6.7 kilometers. The distance traveled, or the path taken, is always your distance, okay? The path taken. And it could be curving like that. The next line is the straight line segment from beginning to end. And that is always your displacement. But displacement requires some direction. And right here, all it's saying is 5.4 kilometers So what do you think we should put in there as direction? Okay. Well, if we look at this and we kind of put our Cartesian plane in there, or your reference coordinates, this would be north, south, east, and west, okay? So you could say maybe northwest, okay, would be your direction. From the north, it is going towards the west, and displacement does require a direction. So displacement is the straight line segment from beginning to end, and we need to have direction. Okay. We want to be able to calculate the difference between these two. Man leaves and walks 4 kilometers east. So again, I want to sketch it out because that will tell me what to do. Don't have to draw the man. All I have to do is put an X, have his starting point, and he goes 4 kilometers east. So 4 kilometers. I am having east going forward in this direction, and I don't have to rewrite the east if I don't want, because the arrow tells me I am going east. Then turns and walks 3 kilometers west. So from this point, he goes back 3 kilometers west. So that's what my diagram is. Then find the total distance traveled. Total distance, well, he went 4 and then 3 kilometers, so total distance would be 7 kilometers. No direction. Okay, and then we're looking for what is his displacement. Displacement is the straight line segment from beginning to end. So I am looking for this section or this section from beginning to where he ended up. And from beginning to end, it is 1 kilometer east. Okay, so that will be his displacement. Delta D will be 1 kilometer east. Straight line segment from beginning to end. Okay, let's try another one here. Shannon is standing on a ledge 3 meters off the ground. Okay, so here she is right there. And it is 3 meters off the ground. She jumps up into the air 1 meter high. So she goes up and jumps 1 meter and falls down 4 meters into the ground or the foam pit. Always straight, wonderful lines there. So, what's its distance? Or what's her distance? What path traveled? 1 up, 4 down. So, distance is going to be 5 meters. What is the displacement? The displacement is just the straight line segment from beginning to end. So start it here and end it there. Okay, and he was going down. So from the start, going down. So your displacement is just going to be 3 meters down. distance and displacement. And that's it. So now we have some questions in your booklet, and that's